In this video, we're going to look at the relationship between something called odds and probability. If you are a follower of professional sports teams or horse racing, or maybe some gambling, you may have heard of the word odds before. Odds is usually communicated as a ratio in this manner, so as opposed to a fraction. The reason being, what's in the denominator here is the probability of an event not happening. So it's not the total of the events that do and don't happen. So this is a more clear way of showing the probability of an event A happening compared to the probability of an event not happening. Or instead of probabilities, it could just be the number of occurrences of that event happening compared to the number of occurrences of the event not happening. So let's do a quick comparison between probability and odds and then dive a little deeper using a tennis player. Let's suppose that the event for this tennis player is winning a Grand Slam event, and A prime is not winning that tournament or Grand Slam event. And let's assume that the tennis player is reported as having a 25% chance of winning. But also the odds for that particular player are 1 to 3 in terms of them winning this particular tournament. So 25% chance of winning, of course, means 25 out of 100, or it means 1/4 as a fraction, or it could be 0.25 as a decimal. When we look at odds, we recognize that there is a 1 chance of winning, 3 chances of not winning, but there are a total of 4 chances altogether, 1 for the win and 3 for not. So the chances of winning the tournament are actually 1 in 4, or 25%, or 0.25. And the odds of not winning are 3 out of 4, which would be 75%, or 0.75, written as a fraction and a decimal, respectively. Okay, so what we have to remember with odds is that neither of these numbers represent the total number of chances. They represent them individually, and we have to add them together to get the total. So let's dive to some more examples. If you roll 2 dice, or 2 die, what are the odds of rolling a 7, 11, or doubles? So we're going back and touching base from a question in our previous lesson in 6.1. And then how does this compare to the probability? So let's begin by looking at the number of opportunities of rolling a 7 are 6 when you look at all of the possibilities of combinations of 2 die rolling together. We're pulling this out from last lesson. The number of opportunities for rolling an 11 is 2, and the number of opportunities for rolling doubles is 6, for a grand total of 14 ways that this event might happen, out of a total of 36 from the grid that we did the other day. So the number of occurrences of the event happening, which is all of these put together, is 14. The number of occurrences of it not happening is 36 minus 14, or 22. So therefore, if we want to write this as odds, here's our yes, event happens, here's our no, event doesn't happen. So we can write this as odds of being 14 to 22. So odds for a win. And odds are always communicated as the win first, or the event happening and not happening left to right, unless it's indicated otherwise. Now when we have odds like this, we also, like fractions, can reduce them to lowest terms. So we notice that both of these are even numbers. We can divide by 2. We can reduce this down to 7 to 11. And those are the odds of rolling a 7, 11, or doubles if you're rolling 2 die. Now, from our previous lesson, from 6.1, you may recall that the probability of getting 7, 11, or doubles was equal to all of these instances out of the total. So 6 plus 2 plus 6 out of 36. And that comes out to 14 out of 36, or 38.8 repeater Okay? So what I want to do is I want to link this and this together using another formula for probability. So the probability of an event happening could also be thought of as being the number of times that the event happens, which we call H, divided by the total number of opportunities for that event, so H plus K. So look what happens if we plug in our values here. We have 14 over 14 plus 22, which comes out to 14 out of 36. Kind of looks familiar. We've seen it up here. Or the probability of event A happening would be 38.8%. So the moral of the story is that if you want to go to the percentage of an event happening from odds, you need to put the odds of winning on top, the odds of both of them together on the bottom, and multiply by 100 to get 38.8%. Okay, which you could also just write as a decimal. If you don't want to multiply by 100 either, you could go 0.38 repeater. Similarly up here, you could put 0.38 repeater, because probability can be expressed as a decimal between 0 and 1 or as a percentage from 0 to 100. Let's try this again. With another example, one that many of you are familiar with. The good old game of Tim Hortons Roll Up the Rim to Win. We are told in Tim Hortons that the odds of winning in Tim Hortons' game of Roll Up the Rim to Win are 1 to 7. What is the probability of winning? Let's call event A the probability of winning something when you roll up the rim. Okay? So again, don't forget, when odds are expressed in this form, we have the wins here, yes, and the losses or the event not happening here. So the probability of getting a prize in Tim Hortons would be equal to the wins over the wins and the losses together. Which means we get 1 out of 8, or 0.125, or if you want to express it as a percentage, it can be 12.5%. So every time you roll up that rim, a 12.5% chance, according to their odds, of getting a prize. And of course, this changes over time as the number of prizes gets claimed as well. Okay, and that's all for another lesson. Let's look at another example. Let's say that the odds of the Leafs making the playoffs are 2 to 15, as deemed by someone in the betting world. Okay, what is the probability that they will make it? So let's have probability of event A being yes, they make it. So the probability of the Leafs making the playoffs would be equal to the odds of them making it over the total of the odds, or 2 out of 17, which comes out to approximately 118, or if you want to write it as a percentage, it'd be about 11.8%. All right, let's try another example. Let's stick with the Leafs and a little bit of vintage hockey here. The odds of Ty Domi scoring in a hockey game are 13 to 15. Let's write that down. What is the probability of him not scoring a goal? Okay, so probability of not scoring a goal means that we're going to look to the number of times that it won't happen here in our formula instead. So we have 15 over the sum of our winning and losing odds, which means we get to 15 out of 28, which can be expressed as a decimal, which is approximately 0.536, or if you wanted to express it as a percentage, you'd multiply by 100 to get 53.6% approximately. Okay, so you have to just be careful what the question's asking for. Is it the probability you're calculating of the event happening, which would be in green? Or is it the probability of the event not happening, in which case we have to look to the red side. Let's look at a couple more examples. Let's actually do a little bit of gambling. Let's say a person bets $10 on the Dallas Cowboys winning the Super Bowl. So it's said that the odds for the Cowboys winning are 3 to 51 for a particular year. Now that's pretty low for the Cowboys most years, but we'll take that for the example. Okay. Now if this person wins, how much will they get? So here are the odds. This person says, I'm going to bet $10 on the winnings. And what we want to know is how much will they win if that happens. So let's set this up as a proportion. So 3 out of 51 is equal to $10 out of what? Now, a couple ways that you can solve this proportion. You could use cross multiplication. That's going to be my choice for doing so. You can also invert and solve for x, as long as you invert both sides at the same time. So I'm going to do 3 times x equals 10 times 51. That means that 3x is 510. If I want to solve for x, I'll divide both sides by 3. Which means my winnings would be $170 if, in fact, they win. And if they don't, I'll lose my 10 bucks. Okay? But we're betting on someone that has low chance of winning, which means that the payout would be much higher if, in fact, they do win. All right, one more example. Let's go back to working with decks of cards. It says in our question in our notes, what are the odds of drawing an ace from a standard deck of cards? And what is the probability of this event as well? Okay, so let's let the event be drawing that ace, event A. So we can do this in terms of the number of instances as opposed to the probability. So what are the number of instances in which you can draw an ace from a deck of cards? Well, there are 4 aces in the deck, so there are 4 opportunities to draw an ace. That would mean that the number of opportunities to not draw an ace are equal to the total number of cards in the deck, which is 52. Subtract those 4 aces. That means the remainder of the cards in that deck, or 48 of them, are not aces. So if you want to express this as odds, don't forget that you're going to communicate the number of times that it can happen versus the number of times that it cannot. Okay, so the odds of drawing an ace are 4 to 48. Oops, I've got this backwards, sorry. Green and red should be the other way around, my bad. Here's green, here's red. There we go. Now, we always try to express odds in lowest terms as well. I notice that both of these can be divided by 4. So if I divide both of these by 4, I can get this to being a 1 to 12 odds. Okay. The probability of this event would be 4 out of the total, 4 plus 48, which is 4 out of 52. And if we punch that in, we get about 0.075 or approximately 7.5. Sorry, it's not a 5, it's a 7. There we go. Approximately 7.7%. Small percentage, not surprising. 4 cards out of a deck of 52, you would expect that to be pretty low. Okay. Then what are the odds of not drawing an ace from the deck? Okay. Well, one simple way that we could do this is just to flip these around, because we know that the event that we're looking for is not drawing that ace. And that's going to happen 48 times. And the event of drawing the ace, of course, is 4. Okay, so the odds of not drawing an ace, this is what I was talking about earlier, that we're going to begin with the event not happening first is when we're communicating the odds. So this would be 48 to 4. Except this time this is the event happening. Or if we reduce it to lowest terms, it would come out to 12 to 1. Okay? And the percentage, the probability of not drawing an ace would be equal to 12 over 12 plus 1, which is 12 out of 13. Which when we punch that in becomes, as a decimal, approximately 0.923, or as a percentage, 92.3%. And it's not surprising that our decimals add up to give a value of 1, and our percentages add up to 100%. And that's it. There's your introduction to odds. Enjoy your practice. Let me know if you have any questions.